How you doing? So let's get started. So we have a question right here. They say which of the following is or are true. Now let me explain to you about a coefficient. Oh my god, it's okay. Something to form a pen. Okay, coefficient meaning, look, if example, if somebody give you, let's say 3x power 4 minus, let's say 5x x power, let's say cube plus 6, say this cube. So if you ask what the coefficient of x squared, x power 4, let's say coefficients of x power 4. So this is my x power 4. So you look the number prior to x power 4. So the coefficients of x power 4 is 3. What are the coefficients of x? Okay. So this is my x, and the number before x is -5. Because whenever you take a number, you must take the sign on the left of a number. So the coefficients of x is -5. What are the coefficients of x cubed? This is my x cubed. What is the number before x cubed? This is my x cubed. The number before x cubed is negative. But if there's no number, means just write 1. So it's -1. The coefficient of x cubed is -1. So that's how you identify the coefficients. So here, let's come to the question. They say the coefficients of x cubed. So these are x cubed here. So the coefficient is the number before -5. So -5 is our coefficients of x cubed. And according to the given here, they say the coefficient of x cubed equal to 5. No, it's not true. It's not equal to 5. So this is not true. Is equal to -5. Let me just ask you a question quick. What is the coefficient of x squared? +4. What are the coefficients of x? -3. So we're done with that. Let's go for the second one. For the second one, they say this expression can be expressed with a rational denominator. Okay. Okay, there's something called rationalize the denominator. Let me explain to you what I mean, rationalize the denominator. Very easy. If somebody, okay, there's a question here. So they give us x plus 1 root and then x minus 1 root. So when you rationalize the denominator, most of the time you do that when you have the roots, and they want you to rationalize the denominator for this case. So I'm going to multiply by this denominator, which is x minus 1. Exactly. So what you do, what is the sign of this denominator is what is positive. So when you multiply, make sure you change the sign of the denominator. You see this positive? Here you're going to put also, you change, you make it negative. But you multiply top and bottom. So you do the same thing for the top and bottom. So that's how we rationalize the denominator. Take this, multiply up and bottom because it is the denominator. But all you do is change the sign. But negative and negative for this case is positive. So it's like it did not change anything. It's like negative and negative positive. So I can just ignore. So what I'm going to do, if there's a root, and it's square and square. As long as the same root type. Like if somebody give you a times b. This time say square root of ab. You write single root ab. Only if the same. But if this is 3, you cannot put them together because the roots are not the same. So it reminds the way how it is. Because they're different. But if it's the same, you can put them together and they write single root a b. Even if it's cube and this is cube, and this is going to become cube. So now for this case, look, cube, square, square. So I can put this on that one together. So then it's going to become single root, and this is going to become x plus 1, and then x minus 1. And then the denominator also, we're going to do the same game. But this is going to become x minus 1 times x minus 1. So this is a difference of 2 squared because x plus 1, x minus 1. So this is going to become x square minus 1 square. 1 square equal to 1. Difference of 2 square. And then we over. This is just x minus 1 bracket square, and then we have a root. See what I'm saying? And another thing also, excuse me, we still have our root here, don't forget. Because like this and this give us different 2 square, but we still have our roots. But for the denominator, see for the denominator, just a second, let me see if they're copyright. Okay, in a question there's nothing. In a given question, this is not there. In a question, sorry. In a question, sorry, I'm the one who copied wrong. So now we see, remember, this is x minus 1 square. So this and this can go. So then we left with x square minus 1, but this has a root, and then over x minus 1. Here you cannot, because it's two different variables. But here it's like one variable, it's like a square. So this and this can cancel. But here it's like two different things. So you cannot say square root of x square minus square root of 1. No, it's unacceptable. You know, I can even prove to you. So it's true that if I take this, finally, you give me that. It's true. So B is true, A is not true, B is true. You know, like I say here, I can prove to you that you cannot say square root of this is the same as square root of x square minus 1 square. Let's assume this is equal to 4. Let's assume. Now, 4, or let's say 2. Let's assume 2. So 2, let's assume. We know, okay, our answer is true, but I just want to tell you, like, this is not equal to that. I can prove to you. Okay. Put here 2. 2 square equal to 4. Square root of 4 equal to 2. Minus square root of 1 equal to 1. Equal to 1. Let's say equal to 1, right? So let's say, okay, put here x equal to 1 in your calculator. So it's going to be 1, square is 1, minus 1, 1 minus equal to 0, equal to, square root of 0 equal to 0. 0 is not equal to 1. 0 is not equal to 1. So that's why you cannot separate these two. It's unacceptable. So according to the question, this is true. Because when we take this expression given, and when we rationalize the denominator, we get that. So it's true by rationalize the denominator. Let's go for the last one. Let me check it. Let me check if it record. I apologize. Yes, it does record. Both. Okay, now for this one here, they say A are all real numbers. If A is a real number, this must be B. Let me see. Yeah, this is B. Man, I need to copy correct. If A are all real number, B are real number, but they say A should not be equal to 0 and B should not be equal to 0. So if this is equal to this, they say then this must be equal to that. But it should not be equal to 0, 0. So let's see if it's true or not. You know what I'm going to do? I'll take this one here, expression. So this is going to be A. Let me find the value of A. So if I square root on the left and square root on the right, what I'm going to get? This and this cancels. So A equal to, this is going to be B. But this must be plus or minus. See? Because we know, for example, if somebody give x square equal to 9, when you square root here, and they'll get x equal to, excuse me guys. Let me put it silence. But for somebody who's calling me, you have to put silence. Okay, cool. These are silence. My apologies, my bad, it's my fault. Okay. So when you square root here, when you square root 9, you get plus or minus 3. Always you have to plus or minus, because look, if you take positive 3 square, you're gonna get 9. Even when you take negative 3 times negative 3, you still get positive 9. That's why when you square, you get plus or minus. So now, for that case, we see the value of A can be either positive or negative B. So you can just say A equal to B. It could be A, it could be either plus B, or A could be negative B. So this alone is not enough. So for that case, this is not true. So only B is true, only this is true. Now we're going to go to the question number 5. Question number 5. Question number 5 is easy. Okay, now, so I want to take this question right here. And then I'll say, first and foremost, look, it's 2x, and then minus 1. Let me go speed a little bit. And then you got x plus 3. And then we got less or equal to 9. I'll expand this phase. So because you cannot solve this quadratic because you have a number. So this must be 0. So I'm going to have to expand it and take over. Now, take multiply. 2x times x, 2x squared. 2x times 3, it's going to be 6x. Now you count this one. This is going to be plus 2x squared. And this is going to be negative 3. Take it over. Negative 9 less equal to 0. Now, this is going to be 2x squared. Excuse me. I made a mistake. I apologize. Apologize. Made a mistake a little bit. So now we go 2 times x, 2x squared. 2 times 3, 6x. Negative 1 times x, negative 1 times negative 3. Take it over. Negative 9 less equal to 0. Now we go 2x squared. This and that is going to be plus 5x. Negative 12 less equal to 0. Now, let's expand it. So we know if we expand it, let's equal to 0. So now we're going to say, let me put silence here. We call it calling me, please, man. You know, people always be calling me. Okay. Okay, so this is going to be x, and this is going to be 2x, because it's going to be 2x squared. Now you go. Okay, this is going to be plus 4, and this is going to be minus 3. Let's see. X times x, x squared. And this is going to be negative 3x, and this negative 8x. Yeah, positive x. So if you expand, it's going to give like that. So now, what we're going to do? Now we say this equal to 0. So we know x plus 4 is going to be equal to 0. Don't worry about this sign for now. And this 2x minus 3, because it's greater or equal, less or equal. X minus 3 equal to 0, because you're going to take this equal to 0 and this equal to 0. So x equal to negative 4. Don't worry about the sign. Now I'm going to show you. And then 2x equal to 3. Because anyhow it's going to be equal. Because they say less or equal. Let's start with the equal. So now x equal to 4. Okay, divided by 2, divided by 2. So it's going to be x 3 over 2. So x equal to negative 4, x equal to 3 over 2. So I'm going to draw my number line here and then test. Don't know if it's easy, man. So negative 4 and 3 over 2. So let's assume this is negative 4. And 3 over 2 is like 1.5. But let's write 3 over 2. So what I'm going to do, I'm going to take negative 4 first and plug in here and see if it's going to be less than 9. And now I'm going to take all the number which is less than negative 4. For example, negative 5, negative 6, and test them in here to see if it's less than 9. For example, let's test by negative 4 itself. If you put negative 4 here, it's going to be negative 8. Negative 8 minus 1, negative 9. So here we have the negative 9. Now multiply negative 4 plus 3 equal to negative 1. So it's going to be 9. Is 9 less or equal to 9? Yes, it's true. So x is going to be equal to negative 4. But we want to see what about negative 5. So yes, x could be negative 4. But I want to find what about negative 5. But for x, we know it's negative 4 also. Okay, now let's take negative 5. I mean the number which is more or less. If you put negative 5 here, it's going to be negative 5 times 2, negative 10 minus 1, negative 11. Okay, multiply. Negative 5 plus 2, negative 2. And this is going to give us positive 22. Is positive 22, is positive 22 less or equal to 9? No, it's not true. So this side here is not true. You can test negative 6, negative 7. It also is going to be not true. For example, negative 7, negative 10, let's say negative 10, negative 20, negative 20 minus 1, negative 21, negative 21. Okay, well, let's multiply. Negative 10 plus 3, 7. Negative 10 plus 3, negative 7. Okay. When you multiply this, it's going to give you somewhere there 100 and bigger number. 147. Is 147 negative? Or positive, sorry. Negative, negative, positive. Is it less or equal to 9? No, it's not true. Because this is bigger, it's positive number. Negative, negative, positive, positive. So here it's not true. So we know, oh, this is not true. So let's test a number in between. From negative 4 to 1.5, because 3 of 2 is 1.5. we can take 1, we can take 0 because they all lie in between here. Like this is 1.5, right? Means you could take 1, you could take a 0, you could take a -1, and we test. Let's test maybe 1, 0 and 1. We don't want to take a lot of them. Okay, 0. If you put 0, it's going to be -1. If you put 0, it's going to be 3. -1 times 3, -3. So is -3 less or equal to 9? Oh yes, -3 is less than 9. So it's true. Let's try 1. You don't have to test a lot of them, maybe 1 or 2. 1. If you put 1 here, it's going to be 2 times 1 equal to 2 minus 1 equal to 1. So it's 1 times. 1 plus 3 equal to 4. 1 times 4 equal to 4. Is 4 less than equal to 9? Yes, 4 is less than 9. So here is true. Let's try here. So first let's try 3 and 2. So 3 and 2, we can plug in here. Okay. 2 times 3 and 2. This and this cancel, so we have it 3 minus 1 equal to 2. Okay. Multiply. Okay. Now this is going to be 1.5. 1.5 plus 3. It's going to be 3, 4.5, which is 9 over 2. This and this cancels 9. Yes, 9 is equal or less than 9 is true. So this itself is true. Now let's take a number after 1.5, right? Let's say 2 here. If you take 2, which is next to it, 2 times 2 equals 4, 4 minus 1 equals 3. Okay, 2 plus 1 equals 5. This is equal to 15. It's 15. Oh no, I think I'm going to mistake. Okay. We say we want to take it. Yeah. Okay. It's 15, right? Yeah, it's 15. Okay, it's fine. 2. 2 times 2 equals 4, 4 minus 1 equals 2. 3. So 3. 2 plus equals 5. 15. It's 15. Less or equal to 9? No, it's not true. So we see any number after this is not true. So the only truth is here. So for that case now, we're going to conclude the value of x is start from -4, including until 3 over 2. So this is our answer for this equation. You see what I'm saying? So we're done with this question. Go to the last simultaneous. So this is our answer for this, which is option. Now we go for the last question. Okay, 3 over x minus 1 over y equals to 8. 2 over x plus 3 over y -2. Okay, so what we're going to do right now, this is easy. So this is simultaneous, but how are we going to do that? Look. Let me find the common denominator of these two. So I'm going to take this y multiplied by 3y, and then there's a minus. I'll take this one x multiplied by 1x, and then multiply these two. X times y equal to xy equal to 8. Then what I'm going to do for the first one is still, I'm going to cross multiplication. So if this 8 means like 8 divided by 1. 8 divided by 1 is still 8. Let's cross multiplication. When you cross, it's going to be 1 times everything is going to remind the way how it is. Because 1 times exactly the way how it is. 8 times xy is going to be 8xy. Let's call it first equation. Now I'm going to go for the second one. I'm going to play the same game. So we done with this? Make sure you show your solution, right? Because I don't want to have a lot of stuff here, that's why. But I'll show you work. Okay, now we count for this. So y times 2, 2y, plus is plus, x times x times 3, 3x, equal, and then we over multiply this 2xy, equal to -2. So now what we're going to do, we're going to cross multiplication. When cross multiplication means this and this is going to give us negative 2xy, or you can start with that first. Whatever you want. X times is going to be 2y plus 3x, because you take this, you multiply for each one. 1 times 2y, 2y. 1 times 3x, 3x, equal to -2 times, it's going to be -2 xy. So we finish this is easy. You know why I say it's easy? Because look here. So I can do the substitution here. Man, how you gonna do that? There's a lot of ways I can go for that. You know? A lot of ways, man. Okay. It's a lot of ways. Okay. The fifth method I could have done. The fifth method. Let me make x subjects here, and then I'll come and substitute in here. So if I can make the x the subjects, and then I'll come and substitute inside here, because I see it's easier for me to make x the subjects. So take this one here, back. So most of the time, make the subjects a single term. Like see, x, this is 2y, 3x, 2y. So just make x. So for this to make subjects, you see negative is going to go over, it's going to become positive x equal, and then take this back because I want to put x alone. So 3y minus 8xy. So whenever there's an x, I'm going to put this value. See what I'm saying? There's a lot of ways you can do. It's a lot of them. Or if you don't want to do that, let me show another way. Let me show another way. I think this can be long. Let me show another way quick. It's a lot of ways you can do that. Oh my God! I just erased this now. I was not supposed to. Okay, so I have to remake again because I was not. My apologies, guys. I was not supposed to erase. Okay, this and this 3y. This and this minus x xy times 8 is gonna be 8xy, just like that. Cool, no problem. So you know another way I can do. Look, you know what I was gonna do. I was gonna say. Okay, I was gonna say, look. See this xy here? xy, right? Look, divide by -2 throughout. So say this, divide by -2, divide by -2, this and this cancel. So xy equal to this. Means xy equal to 2y plus 3y over -2. Take this, substitute in xy here. So I'm going to say 3y minus x, don't worry about x, equal to 8. What is my xy? 2y plus 3y. So this is the first equation, and this was the second equation. Okay, 2xy plus minus 2. Okay, -2, 1. If you divide by -2, it's going to give you -4. So 3y minus x equal to -4. 2y, because this in this cancel, plus this is x, 3x plus 3x. So I can multiply that out. So this is going to be 3y minus x equal to -8y minus 12x. Okay, let's put x together. This with it. So I can take this one here. So it's going to be positive 12x minus x going to be 11x. Equal, or should I go slow? Okay, let me just go slow so it's not going to confuse you. This -x, -12x come back is going to be positive 12x equal. On the right hand side, we're left with -8y. You go over, so -3y. This is going to give us 11x equal to -11y. So I can get x. How am I going to get x? Divided by 11, divided by 11. This and this cancel, so x equal to -y. Also, the value of x equal to -y. Okay. So for that case, I can substitute in any of these equation here, or here, anyone for me to get the value of y. Okay. X equal to -y. Okay. Let's come here. Let's substitute here. So it's going to be 3y minus, what is x? X equal to -y. So it's going to be -y equal to 8. What the value of x is -y times y. So now we can get the value of y because this is going to be negative positive. So it's going to be 4y equal to, okay, let's put this one. This is going to give us -8y squared. -8y squared. So I can take it back, and this is going to give me, first I can divide by 4, divide by 4. Okay, let's go step by step. I can just divide by 4. Okay, let's say 4y plus 8y squared equal to 0. I can take 4y out. And then here, it's going to be 1 plus 2, 1, y equal to 0 because it just factor out for y. So this equal to 0 and this equal to 0. So for y equal to 0, for y equal to 0, let me just finish up here. For y equal to 0, so divided by 4, so y equal to 0, or 1 plus 2y equal to 0. 1 plus 2y equal to 0. So take over 2y equal to negative 1 divided by 2, or y could be equal to negative a half. So y could be equal to 0 or y could be equal to a half. Okay? If y equal to 0, we can get the value of x here. Because if this is 0, x also is going to be equal to 0. Okay, let's go. If y equal to 0, the value of x, y equal to 0, x is going to be equal to, look, it's going to be 0, negative, which is just say x equal to 0. When y equal to half now, when y equal to half negative a half, put here negative a half, look. It's going to be negative a half, positive a half. And then x equal to positive a half. You see what I'm saying? So either 0, 0 or either 0, 0. So finally, for this equation, which is a good question, very interesting question, I will say either x could be equal to 0 and y equals to 0. Or x equal to positive a half and then y equal to negative a half. So it's all depend on your option. You have to look. Okay, x a half, y negative a half. Which should be option 1. A is positive a half, y negative a half. Okay, cool. Oh my God, so we're done with all the questions. Okay, so thanks a lot. You FaceTime here, please come here. I'm gonna respond to all the comments, okay? So leave the comments below. I'm gonna respond to your comments. Okay? Ask me any question. Leave the comments. Subscribe, don't forget, and like. Click the like button because very, very important. When you click the like, means more people. You're gonna have more people to reach the video. Thanks a lot for your time. Peace. Appreciate it.